Watch points are a useful feature to know about in GDB. What are watch points? So sometimes you have examples such as this program here, where the state of the program changes, okay, but the change occurs somewhere else in the program due to some memory corruption. So I create an example for this here. Let's say the main program is shown here. Let's say I'm getting an invalid pointer IP. Okay, why is it an invalid pointer? It's an invalid pointer because it's returned by this function, whereby I take a local variable. I am taking the address of this local variable, and the local variables go out of scope of the function returns. So taking the address of a local variable is not a good thing. By the way, the reason I took this address and added 3 to it is because if I hadn't done that, one reason. If I hadn't done that and compiled this program, in fact, GDB would have told me a function returns address of a local variable. And remember what I said about not ignoring compiler warnings? This is one we don't want to ignore. It's okay, so I'm going to trick the compiler into not giving me a warning by adding 3 to it. Okay, now this throws the compiler off. The compiler doesn't know is what I'm doing good or not. Won't say anything. So here we're returning an invalid pointer, okay? And it points to some local variable, the vicinity +3. And then I'm writing a function here. This is a simple recursive function, and it recurses down from 10 to 0. So you see a recursive function. And I'm passing along this invalid pointer. And when that function reaches the bottom of its recursion, then that invalid pointer that's being passed along is being dereferenced, and it sets its destination to 43. Okay. Meanwhile, this function recurs. So it's a very simple function. It takes an n and recurses, and then it returns n. Okay. So this function always returns n. So if this code works correctly, then the value of b that's being printed out here, the return value of recurse, should be what?
43.
Should be 10. So. Let's run this program, and it turned out the value is 43. Okay. The question is why? I mean, you can guess the answer, which is that somehow this access of that illegal pointer changed the value of n, such that when it was returned, that it turned from 10 to 43. But let's assume that we didn't know that this access occurred here. Let's assume that this access occurred somewhere in your program. Okay, you don't know where. You can use a watch point to find out how. The way you do it is you start GDB, you break in main, you run to it, you skip over this function, you step into recurse, and now you set the watch point. The watch point is to say watch, and you say the expression that you want to watch. In this case, n. Okay. So what you're telling GDB is, I'd like you to stop whenever this variable n changes, okay, no matter where or how. If it changes through this direct assignment or through some pointer elsewhere, it doesn't matter. So then I can say continue, and continues, and now it says, okay, this hardware watch point was reached. The old value was 10, the new value was 43. This is where the corruption occurred. And then I can look at where that happened. First of all, the corruption happens at the end of the recursion. Well, that's because the function was written like that. This corruption here happened at the end of the recursion, just to show you the full function. So here's the function. Okay. We recurse down, at the end we do the corruption. And in addition, you can now see what did that. So it was in line 17. So if I do list buggy recurse C17, well, the line is 17 because the breakpoint stops right after the instruction that triggered the corruption. So I can look again at the current stack point, at the current program counter. This is right after. So in this case, I would need to be looking before x86 has a variable length instruction set, so I cannot compute what instruction it is. So I disassemble the entire function. I know that recurse plus 50 is right after where the problem is. So I disassemble it. This is right after where it is. So this must be the instruction where the problem occurs. Okay. So in fact, it is a load, a store in fact, of 2b, which is 43, to EAX, and here EAX is this value, which was that invalid pointer. And it just so happened that this pointer pointed to exactly where the first function stored its value of n. And this is what corrupted the value of n. If you look at this here, this is the value of n that was 10 being passed in, that should have been 10 being passed out, but during that recursion, it was changed to 43, because that pointer happened to point exactly where this function stored that variable. Okay? And as you might guess, I actually did this intentionally by setting the pointer up here, because I know how the x86 stores its variables, and that is how I was able to compute it. But the point to take home here is that let's say if you hadn't seen this, if this is somewhere in your program where you're dereferencing some invalid pointer, and it just so happens to corrupt one value, when you debug this, you debug and say, oh, this value up there was correct, and now down there it's no longer correct. Okay. Where did it change? Somewhere you call some function, it does something, you don't know where the corruption occurs. With a hardware watch point, you can say, watch this memory address, watch this variable, and then GDB will stop whenever that is changed. And it's done efficiently in using hardware debug register, the x86 has 4 of them. Yeah.
Can you set constraints on your variables to say, marching along from 1 to 10 that looked correct, but 43 would look wrong? So watch it, and if it ever jumps beyond 10 or
conditional watch point? Right. Yeah, I think so. You'd have to script that, I think. Which leads me to maybe the last point number, which is that in GDB you can also script things. So you can write little programs. Here's an example. Little scripts. You can define a function, and within that function you can essentially execute GDB commands. So for instance, here's a GDB command you can call BT for backtrace. And so you can define hooks, let's say hook stop, that would be actually where execution stops, as would be the case when the watch point is reached. And then you can do something, you can script something, and you could implement such a logic.